Hello, Mzansi. Welcome to Mzansi Maths Coach channel. Uh, this channel is all about teaching mathematics to the secondary school learners across the board. My name is Mameja T from South Africa, Mpumalanga to be specific. Yeah, so today, guys, we are going to be learning mathematics. The focus is in grade 9. So this is actually a revision for paper 1, which is actually final examination. The reason why, guys, I projected term 1 and 2 is that most of these topics which are going to come in paper 1 are based in work from term 1 and term 2. So the focus generally is going to be on term 1 and term 2 work. So yeah, guys, and just to mention a few things before we start officially is, yeah, we are going to be actually treating a question paper. We are going to be treating questions. So these questions, we compiled them using previous question papers. So we have been looking at previous question papers from different provinces. We try to cover as many questions as possible. So bear with me. I'm going to be using a pen tablet to write. So if there are questions which you want to try before you can even, or before we can even do the answers, you can simply pause the video. After pausing the video, then you can try to work it out. Then after, you can just resume the video just to check how I am going to do it. So guys, I'm going to be your coach today. So hence Mzansi Maths Coach. So yeah, guys, I hope we are going to enjoy. I advise you that for the sake of data, since data is very much expensive, guys, I advise you to just maybe download the video before you can even watch, so that you can watch it offline as part of your revision. So guys, without further ado, let's get straight into it. So yeah, guys, the first question that we are going to be dealing with is the multiple choice question. So on a multiple choice question, guys, we're only going to discuss, I'm not going to be very long in explaining a lot of things. The first one is complete the sentence, the sum of money that is borrowed or invested. It's called, so in some books, guys, they say the amount of money borrowed or invested. What do we call it? So this falls under financial math, simple and compound interest. So the amount of money borrowed, guys, it's principal amount. So your answer there is number B. So number 2, they say a train traveling at 40 kilometers per hour takes 3 hours for a journey. So they gave us 40 kilometers per hour there. They say it takes 3 hours for a journey. So how long will it take the train to complete the same journey traveling at 90 kilometers per hour? So now, guys, there, the question actually there is how long will it take? So how long will it take? They're looking for what? So that will mean they're looking for a time. So how long will it take the train to complete the same journey? The same journey, meaning to complete the same distance. So, and they did not give us distance there. They gave us distance in terms of speed. So 40 kilometers per hour, guys, is speed, and 3 hours is time. So that is how they gave us a distance. So we know from the formula that speed is equals to distance over time, and the distance now is equals to speed multiplied by time. So guys, I also suggest that you must actually know this formula, or these formulas, or this formulae. So distance is equals to speed times time, and the speed is 40 kilometers per hour. The time is 3 hours. So now the distance now is going to be 40 times 3, it's 120 kilometers, because the distance, the speed is given in this kilometers per hour, so the distance must be in kilometers. But are they looking for distance? No, guys. How long will it take the train? So they're looking for time if the distance does not change, and the only thing that changes there being the speed. So guys, the speed, you know, or you would know by now that the speed should be distance over speed. So the time should be distance over speed, and the distance, it was given in a form of speed and time, and we worked it out to be 120 kilometers per hour. And the time, no, the speed now, it's 90 kilometers per hour. So guys, 120, when we divide it by 90, let me put some calculator there. Guys, I'm trying to load a calculator there. Ne? Okay. Do you want to know? Okay. Let me put a calculator there. 120 divided by 90 and see how much it is. 120 divided by 90. So that is 1,33333. So I can simply close it if I'm done using it. So that is 1,33333. Okay. Let me push it that side. Okay. So I'm sorry for that delay, guys. That is 1, that is 1,33333 hours. 1,333. So it's a recurring decimal. So hours. So that is the time there. So, and 333, guys, is going to be, so meaning it's 1 and 1/3. So if we need to write this in a form of a decimal, so this is 0, or let me write in a form of decimal, 120 over 90. So 0 and 0 will cancel. Then we'll say 9 into 12, it goes once. A remainder of 3 over 9, which can be written as a one whole number, 1 over 3. It's 1 and 1/3. And 1/3 of an hour, it's 30 minutes. Sorry, it's 20 minutes. So this is going to be 1 hour and 20 minutes, guys. 1/3 of 60 minutes is 20 minutes. So this is your answer there. Number 3, complete the following. Guys, we just complete there. I think we can work it out very quickly. So to work it out, let me push it up so that I become as quick as possible. So let me activate my pen. So that is 2x into x minus 2 minus 5, sorry, minus open bracket, x minus 5 into x. So guys, which property are we going to use there? Guys, we have got a bracket and a bracket there. We are going to use the distributive property. If you remember the distributive property there, 2x into x minus 2. So we multiply 2x with x, we again multiply 2x with negative 2. So 2x multiplied by negative 2, sorry, multiplied by x is going to be 2x squared. Then 2x multiplied by negative 2, it's negative, sorry, it's negative 4x. So 2x times negative 2, guys, is negative 4x. Then minus is this minus, ne? Guys, again, if you look at this, there's this bracket times x. So we still apply the very same property, which is the distributive property. So x times x and x times negative 5. So which is going to be x times x, which is going to be x squared. Then x times -5, which is going to be -5x. So now we now to work out this bracket is going to be 2x squared minus 4x. Then negative times x squared is going to be negative x squared. Negative times -5x, which is going to be positive 5x. So the reason why, guys, I put this inside the bracket so that it's not going to be affected by this negative there. So your answer now, if we add like terms there, this and these are like terms, 2x should go, 2x squared should go with negative x squared, and negative 4x should go with plus 5x. So those are your algebraic expressions. So this is 2x squared minus 1x squared. So x squared is the same as 1x squared, which is x squared. Then negative 4x plus 5 is the same as negative 4 plus 5 is 1. So negative 4x plus 5x is equals to 1. So the sign there is going to be positive. Positive what? 1x, which is x. So it means there the answer is x squared plus x, which is number B. That is your answer there. Okay. So the last one, guys, is the diagram number 4. The diagram pattern below consists of crosses or is made by crosses. Sorry, let me drink some water. How many crosses will be there in diagram 6 if the pattern continues? So guys, these are number patterns. So the first one there is 2. The second one there is 1, 2, 3, 4, which is 4. So this one is 4 plus 4, which is 8. So if we investigate this pattern, it's 2, 4, 8. And they want to know in the sixth diagram. So from 2 to 4, 4 to 8, I think they multiplied by 2. So it's a times 2 there. 2 times 2 is 4. Then again, 4 times 2 there is going to be 2. Then from this one to the next diagram, it's going to be 8 times 2, which it will consist of how many? 16 crosses. Then again, 16 times 2, which will consist of 32 crosses. And they are looking for what? They are looking for pattern 6 or diagram 6. So this is the first 1, 2, 3, 4, 5. And the last one, which is going to be times 6 times 2, which is 64. So this is diagram 4. Diagram 4. So this is diagram 5. And this is going to be your diagram 6. Sorry for that. Okay, that is the first page, guys. Your answer there is number C, which is 64. Now we need to go on to the next page. Yeah, that's your next page. Can we zoom it in and try to bring it down? Okay, guys, let's quickly proceed to the next page. Number 5, which one of the following lies between 0, 0.01, 0.07 and 0.08 in the number line? So they are looking for the number amongst all these numbers there, which is found between 0.07 and 0.08. So guys, if they ask a number between two consecutive numbers, or if they ask you a number between any two numbers, you must know that they are looking for an average, what sometimes you prefer to call a mean. So in this case, how do we find an average, or how do we find a mean between these two numbers? You simply have to add the two numbers and you divide them by 2. So if the number is 0, 0.07 plus 0, comma 0.8. So these numbers, they must all be divided by a 2. So when we add the two numbers, let's open our calculator very quick so that we do it a bit faster. 0.07 plus 0.08. 0.07 plus 0.08. So that is 0.15. So let me close it. So the answer there is 0.15. The answer there is 0.15. Sorry, it's 15 there divided by 2. And when you divide 0.15 by 2, let's again go back to a calculator. 0.15 divided by 2, 0.15 divided by 2 is 0.075. So 0.075, let me close it. So the answer there is 0.075. So which is going to be number C. Okay. Now let's go to number 6. Let me push it up. They say if 4.5 kg of sugar cost 36 rands, what will 2.5 kg of sugar cost? Okay, guys, this one, I think you can also use proportions. I think the simplest, because guys, there are so many ways to solve these problems, but every time I'm trying to use the shortest version or the shortest solution, which I can use. So if 4.5 is equivalent to 36 rands, so this side is your kgs, and this side is your money in rands. So 2.5 kg will cost how much? So we don't know what it will cost. Hence, I put X there. Hence, I put X there. So you can use ratios to solve that one. And if you use the ratios, if 4.5 is to 36, then 2.5 is to X. How can you solve for X? Which is going to be the cost of in rands of 2.5 kg of sugar. So you can just cross multiply. So this one you multiply by that one, and this one you multiply by that one. So it's going to be 4.5 times X should be equals to 2.5 times 36. Then this is 4.5x is equals to 2.5 times 36. So let's quickly open the calculator. Let's quickly open the calculator there. It's 2.5 times 2.5 times 36 times 36, which is 90. Let me push it downwards, which is 90. So it's 90. Let me close it. So there is 90 there. It's your 90. So now it's 4.5x is equals to 90. Then you can divide both sides by 4.5. You divide by 4.5. Then 4.5 and 4.5 will cancel eventually. Then your x is going to be 90 divided by 4.5. We can do the same thing. a calculator there. Then it's 90 divides by 4, comma 5. So that's 20. Close. So your X is 20. So which is 20 rands? Because it's money. It's going to be 20 rands. Then you go, you look for 20 rands. That's A there. Number 6, it's A. Okay, done with number 6. Now we go to number 7. So number 7, which is 1.6, or the next question, which is 1.6. So the general rule for the pattern 3, 7, 11, 12 is, in fact, here we need to do the general rule. Guys, you must know that in multiple choice, it doesn't necessarily mean that you must guess the answers. You work out the problems, check the answer, and you compare it with the options that are provided to you, or with the choices that are provided to you there. So 3, 7, 11, and 10. Guys, in patterns, normally if they want to ask you about the general rule or general formula, the nth term, or whatever you may call it, they actually would want you to investigate the pattern. In most cases, check if the pattern is extended by adding the same number. That is what we call, or by subtracting the same number. That is what we call a common difference. Check if the pattern is also being extended by multiplying with the same number, which is called constant ratio or common ratio. Or if we divide by the same number, it's still your constant or common ratio. Or check what is actually happening. Maybe the relationship between the nth term and the position of a term. So in this case, it's 3, 7, 11. So if you look at this, guys, from 3 to 7, they added a 4 there. Then from 7 to 11, they did the same. They added a 4. Then from 11 to 15, they also added a 4 there. So D, which is common difference there, it's 4. So they are adding every time with a 4. How do we find the general rule? General rule must always be in a form of Tn is equals to, then you take your D, your common difference, because there's a common difference there. It must be multiplied by the position of a term. So if a pattern is extended by a common difference, we take that common difference, we multiply it by a position of a term. So this N stands for a position of a term, or what we call a term position. A term position. So then now we are going to check if this rule is true. If we want to calculate term 1, which is T1, so in the place of N, I'm going to put 1 there. So which is 4 times 1. I get what? I get 5. And instead there, my term 1 is 3. So from 5 to 3, I must subtract 5 by a 2. So it means every time I must do what? I must multiply a position by 4 and subtract a 2 to get my general rule. So this is how a rule is found. So let me repeat. How did we find that? We first investigated the pattern there. So we realized that this pattern has a common difference. So what do? You say Tn, because it must start with Tn. To find the nth term, you take that common difference, you must multiply it with the term position. Then we are going to add or subtract with a constant with the same number. So in this case, a constant is -2. So every time, so our D is what? Our D is 4 times N minus 2. So that is how we find the thing. So the next one, even if it's not numbered, guys, even if it's not numbered, guys, we can work it out. It doesn't matter. They say prime factors of 30 are. So guys, prime factors, prime factors. How do we find prime factors? We find prime factors by using prime factorization, or we can use prime factorization, we can use the ladder or table method, or we can use the tree method. But if we have to use the table method, it's going to be 30. Then we divide by the first prime number, which goes into 30, or the first prime factor of 30 there, which is 2. So 30 divided by 2, it's 15. Then we look at 15. 15 can be divided by 3, 5 times. 5 can be divided by 5, which is 1. Guys, when we do prime factorization, once you finally find 1, it means you are done prime factorizing. Therefore, 30 is what? Is 2 times 3 times 5. So that is how you write 30 as a product of its prime factors. So, which is going to be number C. Okay, what will 20 kg bag weigh if its mass is increased by 40%? Increase by 40%. So we need to know 40% of 20 kg, and we need to add it to 20 kg. So in other words, it's going to be 20 kg plus 20 kg. When it's increased by 40%, it must be 20 kg plus the mass of 40% of 20 kg. So whatever that we need to work out here, we need to work out 40% of 20 kg, which is 40 over 100. So 40% means 40 over 100. Of means times 20, which is 20. So this is the same as 0, 4 times 20. So 0, 4 times 20, we can work it out here very quick. Zero, 4. Okay. 0, 4 times 20. That is what we are trying to solve there. It's 8. It's 8. So, okay, it's 8. Okay, let me pause. Okay, guys. Okay. This is 20 plus 8, which is going to be 28 kgs. So that is your answer. So guys, we are done with page 1. Now we can go to, in fact, we are done with page 1 and 2. Now we can go to page 3. Then let me start by zooming. Then scroll down. Question 2. Question 2, guys. Question 2, guys. Question 2, guys. Guys, it's a bit hot. My throat is getting a bit dry. Please bear with me. Okay. Question 2. Given the list of numbers 5, square root of 25, 11, square root of 5, cube root of 125, negative 14, pi, negative 3 over 2. Write a list of the following numbers. The first one, all rational numbers. They want all rational numbers. Guys, you remember the rational numbers They say rational numbers are the numbers which can be written in the form A over B. Let me write them. Let me do something that side. They are the numbers which can be written in a form A over B. But we know that B can never be 0, because once you divide by a 0, it becomes undefined, it becomes non-real. So any number which can be written in a form of a fraction. So rational numbers, they include all integers. So let me write rational numbers so that we clarify them, so that it becomes easy when we want to classify them. Rational numbers. So the first ones are all integers. Why integers? For an example, integers are numbers starting from negative infinity to positive infinity, including 0. So these are the example of integers there. I started with -2, -1, 0, 1, and 2. They include whole numbers. Whole numbers, we know, guys, are the counting numbers starting from 0, 1, 2, 3, up to infinity. They include natural numbers. Natural numbers are counting numbers starting from 1, 2, 3, up to infinity. So rational numbers, they include these numbers. They also include recurring decimals. Recurring decimals and terminating decimals. Terminating decimals. Okay, guys, so when we talk of recurring decimals, what are we talking about? Recurring decimals, we're talking about a number such as 0, 3. So the 3 or the decimal 3, it recurs up to infinity. And this can also be written as 0, 3. Then you put a small dot there, which shows that this is 0, 3. And terminating decimals, we talk about a decimal which terminate, which end. For an example, 0, 0.75. So it terminate at 5. So this is a terminate. So all these types of numbers are rational numbers. Then irrational numbers, so that I clarify this thing, irrational numbers are numbers which cannot be written in a form of A over B. So unlike these ones, so there are numbers which are besides these ones. They cannot be written in a form A over B. So an example of these numbers is pi, y, pi. They also include square root of numbers which are non-perfect square numbers. So these numbers, they include non-terminating, and non-recurring decimals. So for example, guys, if you punch pi in a calculator, you would realize that pi does not terminate. So it has infinite number of decimal places. And those decimal places, they do not recur, meaning they do not repeat themselves. So it's pi, it's a square root of this type of numbers, which are not perfect square numbers. So let's go back to our question. So if we are looking for rational numbers now, remember guys, I said rational numbers, they include all integers, whole numbers, natural numbers, recurring decimals, and terminating decimals. So let's identify them from there. So we have 5. Yes, 5 is a rational number. Why? Because 5 is a whole number. It's an integer. It's also a natural number. And all those are rational numbers. The square root of 25 is 5. So it means it's a rational number. So 11 is an integer. It's a whole number. It's a natural number. We can write it. Cube root of, oh, before that, we have square root of 5. Square root of 5, guys, is not a rational number because I said square root of a number, which is not a perfect square, will be a non-recurring and non-terminating decimal. So you punch this, you'll realize that the decimal do not end. Even on a calculator, it may look like it's the end of the decimals, but they proceed. So cube root of 125, which is 5. So it's a rational number. Negative 14 is an integer. All integers are rational numbers. Then we have a pi. A pi, it's a very good example of an irrational number. So a pi is not rational because it has non-terminating and non-recurring decimal. Then the last one is negative 2/3, which is the same as negative 0.666666666. So it's a recurring decimal, and all recurring decimals are rational numbers. So irrational numbers, guys, if you check almost every number there was rational. The only numbers which were not rational was pi and square root of 5. So this is just going to be pi and square root of 5, which are non-recurring decimals. So recurring decimals. So we talked about this number, negative 2/3. We said this is the same as negative 0.6666666. Guys, you can easily check the value of these numbers by using a calculator. So there's nothing wrong in doing that. So we now need to isolate all prime numbers from the list. So guys, remember the prime numbers. They said that a prime number is a number, or it's actually a whole number that has only two factors, which is 1 and itself. So there's first one, which is 5. 5 can only be divided by 5 and 1. And we can say also square root of 25 because we know it's 5. Then 11 can only be divided by 1 and 11. A cube root of 125, we know it's 5. And those are the only prime numbers from the list. Okay, guys, now we can move on to question 2.2. Question 2.2, and I would want to go. They say a ratio of boys to girls in a choir at Rorobani Secondary School is 4:5. If there are 60 girls in a choir, how many are boys? So they gave us a ratio of boys to girls. So they gave us a ratio of boys to girls, which is 4:5. Then they also gave us, if there are 60 girls in a choir, how many are boys? Okay, so that is not a total there. So that is not a total, it's just the number of girls. So, yeah, if there are 60 girls in a choir, how many are boys? So we can work it out like this. Guys, please, we need to be able to differentiate between all parts, like a total, and when one part is given. So this is not the same as all parts. So this 60 is only for girls. So they say the ratio is 4:5. 4:5. So this is boys. This is for girls. And they say the girls are 60. If the girls are 60, how many are boys? So they need to be more than 60, both boys and girls. So I normally want to do it like this because it's much easier when you do it like this. You can easily cross multiply. Then you also cross multiply that one. So this is x times 5 is equals to then 4 times 60. So x times 5 is 5x. 4 times 60 is 240. Then now you can divide both sides by 5 just to find x. X is going to be the number of boys, right? Then 240 divided by 5. Then 240. It's 48. 240 divided by 5 is 48. Okay. This is 48. Okay, it's 48. So it's 48 boys in a choir. Done with that one. Let me erase. So the next one, they say 3, so 2.3. 2.3, Levo wants to borrow 25,000 at Mashonesa Bank that he must pay for 5 years at 15% interest compounded annually. How much money should Levo pay back to the bank in full after 5 years? Okay, guys, they gave us Level 1 to borrow 25,000. So amount of money borrowed. So guys, we know want to borrow. So this becomes our P at Mashonesa Bank that he must pay for 5 years. 5 years becomes time T at 15%. So this becomes our interest, which is what? Rate of interest. It's our R there. Interest compounded annually. Guys, we're looking for compound interest there. How much money should Level pay back to the bank in full after 5 years? So, guys, how much money should Level pay back to the bank in full? So, what are we looking for? We are looking for an accumulated amount. An accumulated amount now is the principal amount plus the compound interest, which is going to be added onto the principal amount. So, how do we do that? So we must use a formula for accumulated amount of compound interest, which is accumulated amount of compound interest is P into 1 plus R over 100, then close bracket to the power of t or raised to t. So principal amount there is that one, which is 25K, then into 1 plus rate of interest 15%, which is 15 over 100. Then time is 5 years because they say it's compounded annually, meaning every time the money is going to be increased by, or is going to grow by 5% every year for 5 years. So now we can just do the math and calculate quickly. open bracket, 1 plus. So 15% is the same, or 15 over 100 is the same as 0, 0.15, then raised to the power 5. Then this is 25,000, open bracket. So this is 1, 1.15. I added this inside the bracket. So you can easily work out this one on a calculator and find the answer there. So let me work it out on my personal calculator. Please bear with me. So this is 1.15 raised to the power of 5. Let me do this. Okay, guys, when I worked this out on my calculator, it gave me 50,000, 283 and 93 cents. So this is the amount of money that Level must pay back to the bank. So that is how it's done. So let's go to 2.4. If Level should pay back the money in equal monthly installments, how much money will he pay each month? Okay, guys, remember this is what Level must pay. Ne? So now they want to know if this person chooses, because this is a loan actually. So meaning this person must pay this money back to the bank in full. This person takes 25,000, he must pay back 50,283. So if this person must pay this money in installment, monthly installment, how much will she have to pay per month? How much he or she, since Level can be a boy or a girl. Okay, let's see. So that is going to be now monthly installment, which is going to be this money, which is 50,283 cents, 283 and 93 cents. We divide by the total number of months in 5 years. So 5 years is 60 months, if I'm not mistaken. So it's 5 times 12 months. 5 years times 12 months, which is going to be 60. So if we take that, we divide it by 60, divide by 60. So it's going to be 838 rands and 7 cents per month. So that is what this person has to pay every month if that loan is approved. Now I want to go to the next question. Before I do that, let me erase. The next question, they say Bongio invested a certain amount into savings account at, so invested a certain amount. So this certain amount, guys, the money invested, it must be P into savings account at 6.5 compound interest. So we're dealing with compound interest. So if the final amount, so the final amount is 15,300 after 5 years. So this final amount is going to be what? Accumulated amount. Remember, accumulated amount is the amount that is the principal amount with interest. So is the principal amount plus interest added. So it must give us an accumulated amount. So they say after 5 years, how much did she originally invest? So how much did she originally invest? So the amount of money invested. So how much should be the principal amount. So here they gave us what? They gave us interest, they gave us the final amount or the accumulated amount, and they also gave us time. So they want the principal amount using what? Using a formula for accumulated amount of compound interest. So we use the very same formula, which is accumulated amount must be equals to principal amount into 1 plus R over 100 close bracket T. So principal amount now, that is what we are looking for. So guys, they gave us accumulated amount, and that accumulated amount or final amount they say is 15,300 to be equals to P. We are looking for P plus the rate they said is 6.5 over 100. 6.5% means 6.5 over 100. Then time they said it's 5 years. So we can go on and do the maths, which is P into 1 plus 0,065 to the power of 5. This is 5 there. So 15,300 equals to P into 1,065 to the power of 5. Then 15,300 is equals to P. Then now we need to work out 1,065 to the power of 5, and we multiply it by P. So it's going to be times whatever that is that. So let me work it out on my calculator there. So it's 1,065. So 1,065 to the power of 5. Which is going to be 1,37. So 1,37 times P is going to be 1,37 P. So which is 1,37 P. So guys, now to solve for P, we can just divide both sides by 1,37. So you divide by 1,37. So you divide by 1,37. You divide this side also by, so this is not 6 guys, it's 0, it's 0. You divide by 1,37. So 1,37 and 1,37 will cancel. So you'll be left with P there. So 15,300 divided by 1,37, which is going to be 11,167.88. So this is 11,167 and 88 cents. So that is the money that was invested initially in the savings account. So we are done with 2.5. Guys, here let me just do a recap before I move on to the next question. Guys, the formula for accumulated amount of compound interest is this one. So this form is the formula for calculating a final amount of what? Of the money which was growing with what? With compound interest. So if they want you to calculate an accumulated amount of the money which was growing with compound interest, this is how it's done. So now if they want you to calculate a simple interest, it will be, or accumulated amount of the money which was growing with simple interest, it will be accumulated amount will be equals to P plus, P is the principal amount, the amount borrowed or the amount invested, plus simple interest. And you know now that the formula for simple interest is what? It's simple interest, it's principal amount multiplied by time multiplied by the rate of interest all over 100, right? So this is how this one should be done. You can just simply do it like this. Accumulated amount will be the principal amount plus simple interest, and this is the formula for calculating simple interest. You can first calculate the simple interest and you add it to the principal amount. Okay, now let's go and do number 2.6. 2.6. Let me start by erasing first. 2.6. 2.6, it says a train. Let me take it up. Yeah, it reads as follows. A train traveling at 40 kilometers per hour takes 3 hours for a journey. How long will it take? Guys, this question I think is repeating. We can pass and do this one. Find the highest common factor and LCM of 30 and 80 by prime factorization. So there they want us to use prime factorization to find the HCF of and LCM of 30 and 80. So we can start by finding the prime factors of 30 and prime factors of 80. So the first prime number or prime factor of 30 is 2. It goes 15 times. 15 can be divided by 3. 5 times. Goes 5 times. Then 5 can be divided by 5. Then once we have 1 as a factor, then we are done. So 30, it's 2 times 3 times 5. That is how we write 30 as a product of its prime factors. Then 80 can be divided by 2. And 2 into 80 goes 40. 40 can be divided by 2. Then 20 times. Then 20 can be divided by 2. 10 times. 10 can be divided by 2. 5 times. 5 can be divided by 5 once. Once we have 1, then we are done. So 80 can be written as 2 times 2 times 2 times 2 times 5. Okay, now we can use the very same factors to find the highest common factor. So how do we use these factors to find the highest common factor? They say the factors go in pairs. So the first pair is going to be 2 and 2, which is the first pair. Then we must multiply it by another pair. So 3 does not have a pair, we pass it. Then 5 has a pair. There's a 5 there and a 5 there. So it's 2 times 5, which is a 10. And now for the LCM. The LCM now, how do we find LCM using the factors? So we are going to write all the factors of 30 and 80. But the ones which are a pair already, we must write them as 1. So for an example, the first pair there is 2. We write it as a single vector. So the idea there, guys, is to write, how do we find this? It must be found by finding a product of unique vectors. So we find LCM by multiplying unique vectors. So the first vector there is 2. We write it as a 1. So there is 3 there also. Okay, sorry, before I write 3. So we again multiply by a 2. So that 2 there. We also multiply by that 2 there. And we multiply again by the last 2. So it's 2 times 2 times 2. Let me erase this one. So it's 2 times 2 times 2, then times 2. So there's a 1 pair there. I wrote it as 1 there. So this was a pair. Then times 3 is unique. Then times 5, which is the last pair. So 2 times 2 is 4. 4 times 2 it's 8. 8 times 2 is 16. 16 times 3. Then whatever the answer, 16 times 3, whatever the answer is, let me quickly work it out. 16 times 3 times 5. So the answer there is 240. So 240 is the LCM. Okay. Let's proceed to the next one. Before we proceed, let's erase. Okay, to question 3. So it says calculate the following without a calculator. So guys, these are integers, and which rule do we apply there? We apply a BODMAS rule. Sometimes we call it a BEDMAS rule. So this E is for exponents. So this can be exponents and surds. Exponents or surds. Okay, now they say BODMAS or BEDMAS. The first one is bracket. What does it mean? What does B or what does bracket mean in a BODMAS? It means if there's something that we need to solve inside the bracket, we need to do it first. Or if there's nothing, we can multiply out the brackets. So, but the other thing is that, guys, the brackets and the exponents, or bracket and surds. When I'm talking about a surd, I'm talking about the square root and cube root. So they can be dealt with simultaneously. So we can do brackets, exponents, and square roots at the same time. So for an example, there is -4 cubed, -4 to the power of 3. So which is going to be negative into 4 times 4 times 4, which the answer is -8. So this one is going to give us -8. So guys, you must be careful. This one is different from -4 in bracket to the power of 3. Then plus square root of 9 is 3. Then times in bracket 4, 5 minus 8 is negative 3. Then minus into negative 3. Now we can go and remove the brackets there. So, which is going to be negative 8 plus 3 times negative 3. Whether we put it inside the bracket or not inside the brackets, it doesn't matter. Plus 3. So now if we apply BODMAS there, guys, we've got a plus there and a multiply there. We need to multiply first before we can add. So this is going to be negative 8. Then 3 times negative 3 is going to be negative 9 plus 3. So negative 8 and negative 9 is going to be negative 17 plus 3, which is negative 14. Okay, that is how it's done, guys. That's one. So, guys, this one you just have to look out for exponents and surds. I think you can even work them out first and you do the others a bit later. Let me pause. Okay, guys, remember they still say without using a calculator. So let's do 3.1.2, which is negative 2 all squared over 4 minus into negative 4 minus square root of 49. Okay, guys, from BODMAS, I said we can work out exponents and surds. So surds, I'm talking about the square roots and cube roots. So this is negative 2 squared, which is the same as negative 2 times negative 2, which is going to give you 4 over 4. So this one is going to give you 4. It's negative 2 times negative 2. Then we can so long remove the brackets there, which is negative times negative is going to be positive 4. Then minus square root of 49, it's 7. We are looking for the number that was multiplied twice by itself to give 49, which is 7. Then 4 over 4, it's 1, which is 4 divided by 4, it's 1, plus 4 minus 7. So 1 plus 4, it's 5. 5 minus 7, it's negative 2. So that is how it's done. So 3.1.3. So it's negative 4 into negative 2 all divided by 8 plus 2 negative 2 cubed over 1 negative 1 squared in brackets. Okay, brackets. Remember brackets first, then exponents and surds. And brackets with exponents and surds, they can be worked out simultaneously. So we can start with this one, negative 4 times negative 2, which is positive. Negative number times a negative number is going to be positive, which is positive 8 over 8. So this is 8 over this 8, then plus. So this is negative 2. This one is the same as negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. Positive 4. Positive 4 times negative, which is going to be negative again, negative 8. Then over negative 1 times negative 1, which is 1. So this is the same as 8. So this is 8 minus 8 over 8, it's 1, plus negative 8 divided by 1, it's negative 8, which is the same as 1 minus 8, which is negative 7. So that is how that should be done. And it is the last one on integers. So I would like to erase. Let me erase so that I can do the others on the same place. Okay. simplify. So those are your exponents there. If you look at that one, you remember that that falls into exponents. Simplify, it's 9p cubed r to the power of -2 q squared all raised to 2. Okay, guys, there, remember, you can use the laws of exponents. If you remember, there was a law which we did. So there's this law, a product raised to a power. You can apply that law there. So it means you are going to multiply exponents there. So which is the same as a power raised to another power. A power raised to an exponent, what do? We multiply exponents. So this is the same as x to the power of n times m. So there you are going to multiply the exponents. So, or if you have something like x to the power of n, y to the power of m, raised to the power of p. So even this one, you must multiply the exponent. So it's going to be x to the power of n times p. You multiply exponent, y to the power of m times p. So the same thing there. So this is 9 to the power of 1 times 2. So it's 9 exponent 1, invisible 1 there. There's invisible exponent of 1 there, times 2. So this 1 times this 2. So this exponent times this exponent. Then p to the power of 3 times 2. This exponent times this exponent. Then r to the power of -2 times 2. Then q to the power of 2 times 2. So this is 9 to the power of 2, p to the power of 6, r to the power of -4, q to the power of 4. So 9 to the squared, we know is the same as 9 times 9, it's 81. Then p to the power of 6. Then guys, we know that we should not write an answer with a negative exponent. So this alone, r to the power of -4, is the same as 1 over r to the power of 4. You know, it comes from that law which says a law of negative exponent. So when a base is raised to a negative exponent, so it becomes 1 over x to the power of n. So we are going to apply the same concept there. So this is going to be 1 over r to the power of 4. So we know it's going to be r to the power of 4. There must be to the power of 4 there. Then again times q. So this is q to the power of 4. Okay, why did this one have to come as a denominator? So this alone, guys, this alone must be written as 1 over r to the power of 4. So it must now become a denominator. So this should be written as such. All right, I hope that was captured. 3.2.2. So this one is -6x squared y cubed all over 3x y squared all raised to 3. Okay, guys, here I think the choice is yours. You can multiply all the exponents with 3, or you can work out the bracket first before you can work out or you can multiply the exponents by 3. So let's work out the bracket first there. So This one is negative 6 divided by 3. We know negative 6 divided by 3 is negative 2. Then x squared divided by x to the power of 1. Same basis, you subtract exponent. So it's going to be x to the power of 2 minus 1. There's an exponent of 1 there, invisible 1. So since the bases are the same, you are going to divide the same basis there. And this is y to the power of 3 minus 2. So y to the power of 3, y to the power of 2, they have the same basis. So you must subtract the exponents, all raised to the power of 3. So what happens here, guys, is I want to work out what is inside the bracket first before I can multiply out with the exponent outside. So, which is negative 2 x to the power of 1. So 2 minus 1 is 1. So 1, whether you write it or not write it, doesn't matter. Y to the power of 3 minus 2 is 1. You close your bracket, raised to 3. So lastly now is going to be negative 2 to the power of 1. There's 1 there. You can multiply now with the power outside. Then x to the power of 1 times 3, y to the power of 1 times 3. So, which is negative 2 to the power of 3. I put it inside the bracket, guys, because it's negative. Né? So, it's going to be negative 2 inside the bracket to the power of 3 because it's different from negative 2 to the power of 3. Then x to the power of 3, then y to the power of 3. Then lastly, this is negative 2 times negative 2 times negative 2. So whatever happens there, it affects the whole thing. So which is negative 8x cubed y cubed. So that is how you solve that one. So lastly, let me erase. Lastly, it's 3.2.3. It is raised to a negative exponent there. Okay. This is 3.2.3, which is 9x to the power of 5 over 3x to the power of 7 raised to negative 2. Raised to negative 2. Raised to negative 2. So the exponent of negative 2 there. Okay, guys, this one, when we have a negative exponent, when everything is raised to a negative exponent, remember there is a law of a negative, a fraction raised to a negative exponent. So when a fraction like this, for an example, when it's a over b raised to the power of n, so this can be written as b over a raised to n. So you can change this and make it, remember we don't want to have a negative exponent. So once we change this and make it positive, so the denominator becomes and numerator swap. So according to this law. So this one, if we want to change this to a positive exponent, so this is going to be 3x to the power of 7 over 9x to the power of negative 5, all raised to 2. Then now we can work out the bracket first before we can raise to an exponent of 2. So this one, guys, is going to give us 1 over 3, then 1 over 3, which is 3 over 9, Then x to the power of 7 divided by x to the power of -5. Same basis, we subtract exponents. So this is going to be x to the power of 7 minus -5, right? All should be raised to the power of 2. So I'm trying to work this out before I'm going to multiply the exponents by 2. So now this is going to be 1/3 x. So 7 minus minus is going to be plus. So 7 plus 5 is 12. So 1/3 x to the power of 12, close, then raise to the power of 2. Now you can work out the, you can raise to the power of 2. So this one now is 1/3, which is to the power of 1 times 2. So then exponent of 1 there. So this 1/3 or this 0.3333 should be 0.333 to the power of 1 times 2. So exponent of the whole thing multiplied by 2. Then x to the power of, this is 12 times 2. You multiply the exponents, which is what? Which is 1/3 to the power of 2 x to the power of 24. So 12 times 2 is 24. So this is 1/3. So it's the same as 1 times 1 over 3 times 3, which is 9x to the power of 24. So guys, here what is important there is to change this if you want to make it a bit easier. Or if you don't want to do it like this, you can simply multiply out the exponents. It is still fine, but I think it's easy first if you change this negative exponent to make it positive. And once you do that, denominator and numerator are going to swap from this law of when a fraction is raised to a negative exponent. We can swap numerator and denominator. So guys, that is all about the exponents. I think we can go to question 4, which is based on number patterns. Then let me a bit. Okay, let me reduce. Okay. Okay, let me do this. All right. Extend the following pattern by writing the next 3 times. So we have 1, 8, and 27. So guys, when we extend patterns, I said you must first check if we are increasing by a constant different. It's like when we adding with the same number. So it doesn't look like we add with the same number there. So because from 1 to 7, from 8 we added 7, but from that 1 to 27 is like by 90. So it is not the same number. Neither did we also multiply with the same number. So now when we look at these guys, where do we recognize this from? Look at the numbers and tell me where you recognize them from. So these numbers, they are called the perfect cubes. So this number 1 there, it was found by raising 1 to 3. So this number there, it was found by raising 2 to 3. So that number there was found by raising 3 to an exponent of 3. So if we take these numbers 1, 2, 3, 4, and we raise them to an exponent of 3, so they are going to give us these numbers. So we call them perfect cubes. So now this is going to be a cube of 4, which is a 64. So this is going to be a cube of 5, which is going to be 125. So this is going to be a cube of 6, which is going to be 260. Okay, that is how you can. So sometimes, guys, check if the pattern is also extended by squaring. Sometimes they can give you 1, 4, and 9. They say extend by writing the next 3 times. So if you look at this number, these are perfect square numbers. So it's a square of 1, a square of 2, and a square of 3. Okay, so meaning this is going to be a square of 4, which is 16, a square of 5, which is 25, a square of 6, which is 36. There. So it's 25 there. No, it's 16 there, sorry. So there is 25, and there is 36. Okay. Now let's do 3.1. Let's do 3.1. Study the geometric pattern below and answer the questions that follow. So guys, that is what we call a geometric pattern. They also give you a table there. So there's figure 1, figure 2, and figure 3. So figure 1, they say number of lines is 1, 2, 3, 4, 5, 6. They say it's 6 there. So figure 2, they say it has 11, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the last figure there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 there. So guys, if you can check what happens there, every time they just add the previous figure with 1, 2, 3, 4, 5. So they add with a 5 all the time. So this one, they also added 5 to this one. So there's a common difference there of 5. So let me confirm this one. If it's 5, so it's going to be 11 plus 12, 13, 14, 15, 16. So this is supposed to be 16, guys. So it's plus 5. They add with 5 lines over time. So since they're adding with the same number, it means there's a common difference there, which is 5. So this one, figure 3, complete the table by writing down the number of lines in figure 3. So figure 3 will be what? Will be 16 there. So write down the general rule in terms of Tn. Guys, remember I said Tn, which is the nth term. You are going to take the common difference, which is 5. You multiply it with the position. Then you check for T1, you must get 6. And if when we replace n with 1, you don't get 6. You must add or subtract with whatever so that it will give you 6. So 5 times 1 is 5, but we want 6 there. You can simply add there with a 1. So it means every time you must add with a 1. You take the 5, which is the common difference, you multiply with the position. The position is position 1, position 2, position 3. Or you multiply it with the figure number. So this is the figure number. You add a 1. Then you get your thing there. So that is the answer. So this one is not the answer. So let me repeat. How do we find a general formula or a general rule for a pattern with a common difference? I said you first need to check if there is a common difference or a constant ratio. If there's a common difference, and for all the rules or general rules, they must start with Tn, which is the nth term. If there's a common difference, we're going to take that common difference. You must multiply it with the 10 position, or you must multiply it with the figure number or the position of the figure. Then you check how much do you add or subtract with. So in this case, when you for term 1, which is T1, in the space of n, we are going to put 1. Then meaning is going to be 5 times 1. And 5 times 1 there, if we replace this with 1, we are getting 5, but we must get 6 there, because the first figure there, or the first position there, we have a 6. So it means we must add there. Instead of subtracting, we must add there. We must add with a 1. So it's a plus 1. So which is going to be your answer. Supposed to be like this. Only for the one with a common difference. Okay. So let's go on to the next page. Let's go on to the next page. Before I go, let me check if there's nothing there. Okay. Okay. All right. Let me push it aside. So question 5, solve the following equations. Solve the following. So those are your algebraic equations. So this is how they should be done. Let me. Okay. The first one is going to be 2.3.2. So guys, please bear with me. Don't pay too much attention to the numbering, because most of these questions were just be taken from previous question paper. So I just compiled them without even changing the numbering. So just pay attention to the type of question. So this one is solve the following equation. So instead of x there, it's y. 6 into y plus 2 minus y is equals to -8. Okay, guys, the very same principle that we apply when we are solving algebraic expressions, I think it is the very same principle that we're going to apply there when we are solving algebraic equations. Ne? For an example, the first one, it's 6 into y plus 2 minus y. So there's a bracket there. The first thing that we need to do is to remove the bracket or get rid of the bracket. So by doing what? By applying the distributive property. Remember the distributive property, you multiply 6 by y. Again, you multiply 6 by 2. So 6 by y is going to be 6y. Then 6 by 2 is going to be 12. Then minus y is equals to -8. So the idea there was just to get rid of those brackets. Then, oh, let me erase this. Guys, let's avoid using 2 brackets when we solve for equations, because it doesn't look nice when we use 2 equal signs. Sorry, I meant to say equal sign instead of a bracket. So let's avoid using 2 equal signs. So now it's 6y plus 2 minus y. So guys, when we solve for equations, remember you sometimes use the additive inverse. So sometimes you can just transpose. So instead of using additive inverse, I just want to transpose. So I normally tell my learners that they can just group terms with unknown on one side, the terms without unknowns on the other side. So there's 6y, 6 with unknown, and a y is unknown. So So they can just group them together on the left, which is 6y minus y, then is equals to, they put an equal sign there, minus 8. Then they take this 2 and take it to the other side. And once this 2 is going to jump the equal sign, it must change the sign. It's like we transpose a 2, right? From positive, it becomes negative. So 6y minus y, it's 5y, is equals to negative 8 minus 2, it's negative 10. So we want to solve for y, not 5y. So we need to get rid of this coefficient there of 5. So how do we do that? By dividing by 5. We also divide this side by 5. So 5 and 5, it's 1. So this is 1y, which is y. So negative 10 by, it's negative 2. So the answer there, y is negative 2. So the next one, which is, please don't mind the numbering. So it's x minus 2 over 3 plus 2 is equals to x plus 1 over 5. Okay, guys, these ones, I can say they are higher order type of questions. So this is plus then. So it's x minus 2 over 3 plus 2 is equals to x plus 1 over 5. So guys, how do we solve these ones? Equations which are involving fractions. So because we are adding there, we are going to use the LCM method. So we are going to look for LCM of x minus 2 over 3 and 2 over 1. So this 2 can return as 2 over 1 so that all these things can be fractioned. X plus 1 over 5. So the LCM of 3, 1, and 5 is 50. So guys, the LCM, remember, we're looking for that number. We're looking for the multiples of 3 and 1 and 5, the one which is the lowest. So it's 50. So what do we do with this LCM? We are going to multiply this fraction, and that fraction. So we multiply all the fractions, the 3 fractions, with 15. So this is going to be 15 multiplied by x minus 2 over 3, then plus 15 by 12 over 1 is equals to 15 1 plus x over 5. And how do we multiply this? We can multiply this by dividing. We can simply divide 15 and 3, or we can simplify, or we can use the highest common factor, and we say 3 into 3, it goes once, into 15, it goes 5 times. So there we are left with 5 into x minus 2 plus, is this plus there. So 15, 1 into 15, it goes 15 times into 12. Then we can divide 15 by 5, or use the highest common factor of 15 and 5, which is 5. 5 into 5, it goes once, into 15, it goes 3 times. There we are left with 3 into x plus 1. Then you close your bracket. Now you can just simply multiply out the brackets. So by applying the distributive property, so 5 by x, it's 5x. 5 times 2 is negative. 5 times 2, it's negative 10. Plus, is this plus 15 times 12? Let me do it very quick, because I'm not sure how much it is. 15 times 12 is 12 by 15. It's 12 by 15, or 15 by 12. 180. Let me close it. So this one is going to be 180 is equals to, apply the distributive property there, meaning 3 times x, 3 times 1. So 3 times x is 3x, then plus 3 times 1 is 3. Then now we can do as such. Like I said, I normally advise my learners to group or to transpose, to group unknowns on one side and the terms without unknown on the other side. So there's 5x there and 3x there. So this 3x can come on the left-hand side. So we've got the left-hand side of the equation and the right-hand side of the equation. So this 3x must come onto the left-hand side of the equation so that it goes with the unknowns are grouped on one side. So 5x, and once a term jumps an equal sign, guys, it must change the sign. So 3x will become minus 3x. So there's any other unknown there. So we can simply put our equal sign. Then we have negative 10, 180, and 3. But we must start with the one which is already on the right. It must go with negative 10. But negative 10 must go from the left-hand side into the right-hand side. So it must change the sign. It becomes positive plus 10. And 180 must also come on the right. It must change the sign from positive. Now it becomes negative minus 180. So 5x minus 3 is 2x is equals to 3 plus 10 is 13. 13 minus 180. So 13 is smaller than 180. So 13 minus 180 is going to be 180 minus 13. It's okay. Let me just make sure. 13 minus 180. 13 minus 180. It's 167. Okay, let me take it there. So this is 167. It's 167 2x. 2x is equals to 167. So in fact, what should happen there, guys? We must get rid of this 2 by dividing both sides. We divide by 2, we divide by 2. So 2 and 2 cancels. Then 167 divided by 2. 167 divided by 2. $83.5. So our x for now is 83. $83.5. Okay, guys, that is how it should be done. Let me just do a small recap. Guys, if you are requested to solve for x, meaning you are given an algebraic equation which involves fractions like this, especially the fractions which have different denominators, you must use the LCM method. So meaning you must find the LCM of all the denominators, what we call the lowest common denominator or the lowest common multiple of all denominators. So in this case, we've got denominator of 3, a denominator of 1, and of 5, which is 15. So you take this 15, you multiply this fraction, you see 15, then you put the fraction inside the brackets. Then plus 15, you put the fraction inside the brackets. Then again plus this one. And guys, the other mistake that I have just done there is to make this 12. This is not 12, it's 2. Ne? I see now. This is 2, not 12. So, but the very same thing I did for 12, which is what you should have done for 2. I don't want to go back and correct it. So, if this was 12, you should have multiplied that 12 by 15. So, I think that can be corrected. I'm sorry, guys. I used 12 there instead of 2. But what is important, guys, is the method, is how it's done. It's not necessarily the answer. It's how it should be done. So we are going to multiply all those fractions by the lowest common multiple. And when you multiply, you can apply the you can apply the highest common factor. For an example, 15 into x minus 2 over 3. So you can just divide 3 and 15 there. So 3, and how can we do that? 3 by 3 is 1. 3 by 15 is going to give you 5. So this is going to give you 5. So this is 1 into 15, it goes 15 times. So hence we wrote 15 there. So this one is 5 into 15, it goes 3 times. So 5 into 5, it goes once, into 15 3 times. So this is 1, 1, 1. So you are left with what? With 5 into x minus 2 plus 15 into 12, or 15 into 2, because there's 2 there. This is mistake, it's supposed to be 2, not 12. And also 3 into x plus 1. Then after, you just multiply out the brackets there. 5 times x, 5x, 5 times negative 2, negative 10. 15 times 12, or 15 times 2. Guys, this is supposed to be 30 actually. This is supposed to be 30, but it's fine. Now, 3 times x, 3x, 3 times 1, plus 3. Then you just now group unknowns on one side, the known values on the other side. So these are the unknowns. They must be on one side. So there was 5 already there. So 3 must jump the equal sign. The reason why it changes the sign. That is how it should be done. Okay. Now let's do 2.3.3. 2.3.3 quickly. Let me do this. Okay, it says Tutsi is currently 2 years old and his sister Camelia is half his age. So Tutsi is currently 2 years old and his sister is half his age. By the time Tutsi will reach 42 years, how old will be Camelia? Okay, let's work that one out. It's a weight problem. Okay, they say Tutsi is currently 2 years old and his sister Camelia is half his age. So meaning Tutsi is 2. So if Tutsi is 2, it means Camelia is 1. So they say by the time Tutsi will reach 42 years, how old will be Camelia? So these people have a difference of 1 year. So Camelia is 1. So when Tutsi is 42, so Camelia will be 1 less, of to this age. So she or he will be 41 years. Because if currently Tutsi is 2 years and his sister Camelia is half of his age, so it means if at the current moment Tutsi is 2 years old, Camelia is 1. So these people have only a difference of 1 year. So if this other one becomes 42, the other one will be 41. So guys, that is how I understand, unless if something is missing there on that question, because they normally don't ask such an easy question, but if everything is fine, nothing is missing, that is how it should be done, unless if something is missing there. So if something is missing, then I don't know. Okay. The next one, guys, let me push it up. Okay, let me push it also to the right so that I will have space to work out there. All right, let me activate my pen. Now, the next question, guys, is still on algebraic equations, what you normally call solve for x. We have 5.2.1, which is 10x minus 5 is equals to 5x plus 30. Like I said, you can simply group unknowns on one side, the known values on the other side. So unknowns is 10x, it goes with 5x. So 10x, 5x is already on the right-hand side. So this is the left-hand side of the equation. This is the right-hand side of the equation. So 10x is on the left. It must go with 5x. And there's 3 on the right already. It must go with -5. So -5 must come onto the right. So it must change a sign. Remember, when a term jumps an equal sign, it changes a sign. So 10x minus 5x is 5x is equals to, so 3 plus 5 is 15. Sorry guys, this is 30. This is 30. So this is supposed to be 35. So the 30, yes, it's 30, it's not 3. Okay. Now 5x is 35. We must get rid of a 5 there by dividing by 5 both sides. So 5 and 5 cancels. So we are left with x. So 5 into 35, it goes 7 times. So that is that one. So the next one is 5.2.2. 5.2.2, which is 2x minus 3 into x plus 6 is equals to 0. Then how that is done? So guys, that is where we apply the FOIL method. If you remember, a polynomial by a polynomial, I taught you to apply what we call a FOIL method. So which we said this one is first and first. Then we do outer and outer. So it's the first and first, outer and outer. So this one, I for inner and inner, then L for last and last. So these are first and first. So it's your first and first. Then now this should be O, which is outer and outer. So this one is out, this one is out as we compare to this one. Then from O you go to I, which is inner and inner. From I you go to last and last. So the FOIL you apply when you multiply a binomial by a binomial. So in other words, you are going to take this 2x from the first bracket, it must multiply by x plus 6. Again, you take the second term there, it must multiply the whole bracket. So this is first and first, outer and outer, then inner and inner, last and last. So we can now multiply out. So first and first, which is first and first term and first term, first term and first term. So which is 2x squared. So now we must go to outer and outer. So which is 2x and 6, which is 2x and 6, which is going to give us what? Plus 18 oh sorry, plus 12x. So this is 12. It's not 18, it's 12. 2x times 6 is 12x. Then we are done with first and first, outer and outer. Now we do inner and inner. So inner and inner is going to be this one's 3, negative 3 and x are inside 2x and 6. So we can call them inner and inner. So which is negative 3 times x is going to give us negative 3x. Then lastly, we do the last and the last. So the last and the last is going to be negative 3 times 6, which is negative 18. Then we have 2x squared. So now we look for like terms. So there are like terms there in the middle there. So 12x minus 3x, which is plus 9x minus 18. So 2x squared plus 9x minus 18. So they are all unlike terms, so they cannot be added. So that is the last one. I mean the final answer. So times 3. So 2 into. So the next one is 5.2.3. Never mind the numbering. I just want to distinguish them from the others there. So this is what we call an exponential equation. How do we solve it? So if we wrote this as an exponent, we must also write this one as an exponent. So this is 2, this is not 2x, guys, it's 2 to the power of x, or 2 to exponent x is equals to, so how can you write 1 over 8 as an exponent? 1 over 8 as an exponent can be written as 8 to the power of negative 1. Where is it coming from? It comes from the law, which the law of negative exponent. If we have x to the power of negative 1, this can be written as 1 over x to the power of 1. The same applies if we have 2 to the power of negative 1, or 2 to the power of negative 2. This is the same as 1 over 2 to the power of 2. So it's the same thing which I applied there. So this 8 now, it can be written as a base of 2. So in a way is to make the bases the same. So this side we have a base of 2. So I need to write 8 in an exponential form in a way that it will have a base of 2. So 2 to the power of x is equals to 8 is the same as 2 cubed. But we know the exponent there is what? It's negative 1. So this is 8 to the power of negative 1. So 2 cubed is still 8 there. So I just want to write it in a way that the bases are the same on the left-hand side and on the right-hand side. So now let me push it up. Okay. Now I have 2 to the power of x is equals to, this now becomes 2 to the power of negative 3. So guys, here, when we solve an exponential equation, the rules are very much simple. It's either we make the bases the same on the left-hand side and right-hand side, or we make the exponents the same on the left-hand side and on the right-hand side. And they say if the bases are the same, both on the left-hand side of the equation and on the right-hand side of the equation, if the bases are the same, they say the exponents are equal. And if the exponents are the same, say these exponents are the same there, therefore it means the bases will be equal. So now that the bases are the same in both sides of the equation, it means the exponents are equal. So this exponent on the left, it must be equals to exponent on the right. Okay, guys, what happened there is, first of all, we changed this fraction and make it a exponent because we want to solve an exponential equation. So 1 over 8, it can be written as 8 to the power of negative 1. Why? Because we know it from there. 1 over x to the power of n, it can be written as what? As x to the power of negative n. So these two things are the same. So once that is changed, 8 to the power of negative 1. Because we are a base of 2, 8 can be written as a base of 2. We know that 8 is the same as 2. 8 is the same as 2 cubed. 2 times 2 times 2 is 8. But already we had an exponent of 1 there. So if we multiply the exponents, we multiply the exponents because of this law. X to the power of n into x to the power of n. It's x to the power of n times m. So if we have a power is raised to an exponent, we multiply exponent. So it's a power raised to an exponent. The reason why we multiply the exponent. So 3 times negative 1 is negative 3. So it becomes 2 to the power of negative 3. So 2 and 2 now they are the same. Once the bases are the same, exponents are equal. Equal, guys. Let me erase. That was that. So the last one, still on solving equations. Still on solving equations. The last one, which is numbered 5.2.4, which is 2 to the power of x minus 1. Guys, this is not 2x minus 1. It's 2 to the power of, or 2 to exponent x minus 1 is equals to 16. Okay, guys, like I said, when you solve an exponential equation, the rules are very easy. Either make the bases the same or make exponents the same. If you cannot make the bases the same, make the exponents. For an example, is it possible to make exponents the same there? No, but is it possible to make the bases the same? Yes, it's possible. Why? Because we have a base of 2 there. Can we write 16 in a way that it's 2 to the power of something? Yes, it's possible. So we are going to write 16 as 2 to the power of something. So 16 is 2 to the power of 4. Why? Because 2 times 2 times 2 times 2, it's 16. Now the bases are the same. They say if the bases are the same, what happens? The exponents are equal. So the exponent on the left-hand side must be equals to the exponent on the right-hand side. So the exponent on the left is what? It's x plus 1. It must be equals to exponent on the right, which is 4. But we want to solve for x. We don't want to solve for x minus 1. So this minus 1, we must transpose it. So when we transpose x is going to be left alone, then 4, negative 1 becomes that side. It must change a sign because it jumps equal sign there. It must change a sign, it becomes positive. So therefore, x is equals to 5. So this is literally the same as 2 to the power of 5 minus 1, which is the same as 2 to the power of 4. 5 minus 1 is 4. So 2 to the power of 4, it's 16. So guys, we are done with equations. Now we go to the next topic or the next question, which is question 6. Question 6, consider the following algebraic question and answer the question that follow. 10x cubed minus 7x squared minus 1 over 2x minus 2. So the first one is 6.1.1. They say how many terms are in the expression above. Guys, how do we count the terms? Terms, they say they must be separated by addition and subtraction. So there's subtraction, subtraction, subtraction. So we have 1, 2, 3, 4 terms. So the answer there is 4 terms. So 6.1.2. What is the coefficient of x squared? The number in front of x squared there. It's what? It's negative 7. So the coefficient of x squared is this number in front of x squared. So we can now go to the next page. We can go to the next page. So 1.6.1.3. They say what term or which term is a constant term? A constant term, guys. Let's go back. So this is actually 10x cubed minus 10x cubed minus 7x squared minus a half x plus minus 2. So if we write it here, we are going to write it as as 10x cubed minus 7x squared. This is supposed to be squared minus 2 1/2 x minus 2. So they're asking which term is a constant term. Guys, remember a constant term is a term without variable. So we have got these variables there, x, x, x. So a constant term is the last one, which is -2. We must take it inside. 2 is not correct, guys. If you write 2 is not correct, it must be written with it. So what is 6.1.4? What is the degree of the expression above? Guys, what is a degree? So let me define a degree first. Guys, a degree is the highest exponent of an algebraic expression. So this one is an exponent of 3, this term is exponent of 2, this term is exponent of 1. So the degree will be the highest exponent, which is 3. So when I just know that a degree is the highest exponent of an expression, determine the value of the above expression when x is equals to -2. Okay, guys, this is where we are going to substitute. We are going to substitute x by -2 in the above expression. So let me take it a bit to the left so that I work there. So we have 10 into, remember for substitution, we use brackets. So when x is -2, so meaning everywhere there's x, we need to substitute -2. So from the expression 10x cubed, so -7 into, in the place of x, we put -2 squared minus 1/2, we use bracket, -2 minus 2. Okay, now remember I said exponent first. We need to solve this exponent first. So this is 10 into, so -2 cubed is the same as -2 times -2 times -2, which is -8. Then minus 7 into -2 squared is the same as -2 times -2, which is 4, minus times -1/2 times 2 is going to be plus. A number times a half is half of that number, 1 minus 2. Okay, this is going to be -80. Then minus 7 times 4 is -28. Then plus 1 minus 2. So -80 minus 28 is going to be -108. -108 plus 1 is -107. -107 minus 2 is -109. Something like that, guys. I might have made a mistake, but what is important today is just the method. I'm not saying you must make mistakes. I'm saying it's possible for me to have made a mistake, but what I care most about in this revision thing is the CM, the correct method. Okay, number 2, 6.2. They say simplify the following. Guys, I'm going to do that a bit quicker because of time. So this one, which property are we going to apply? We are still going to apply the distributive property. So what is outside the bracket must multiply everything inside the bracket there. So it's negative 3x. It must multiply everything inside the bracket. Negative 3x times 4x squared is going to be negative 12. 3 times 4 is 12. X times x squared, it's x cubed. Then negative 3x times negative 7x. Negative times negative is positive. Then 7 times 3 is 21 x squared. Then negative 3 times negative 11. Negative 3 times 11 is negative 33. Then x, because it's negative 3x, it's not negative 3. So after multiplying out, we check if we can add like terms and like terms. We can add like terms, sorry. So there are no like terms there because of different exponents. So we are done. So the next one, 6.2.2, which is a square root of 100x cubed. Sorry, square root of 100x to the power of 6 plus a cube root of negative 64 y to the power of 9. Okay. Now a square root of 100 x to the power of 6. So we are looking for square root of 100 and a square root of x to the power of 6. A square root of 100 is 10. Why? Because 10 times 10 is 100. Then a square root of x to the power of 6. We are looking for that which was multiplied twice by itself to give x to the power of 6. It's x to the power of 3. Why? Because x to the power of 3 times x to the power of 3 is going to be x to the power of, so we multiply powers of the same basis, we add exponents, which is going to be x to the power of 6. So meaning the square root of x to the power of 6 has to be x to the power of 3. Because when you multiply x to the power of 3 times x to the power of 3, you get x to the power of 6. Then plus a cube root, guys, there's a 3 there, a cube root of negative 64. So that actually it's a cube root of negative 64 and a cube root of y to the power of 9. So a cube root of negative 64 is negative 4. Why? Because negative 4 times negative 4 times negative 4 is negative 64. And a cube root of y to the power of 9 is y to the power of 3. Why am I saying that? Because y to the power of 3 times y to the power of 3 times y to the power of 3. So they say if you multiply powers of the same base, what do? We add exponents. Plus 3 plus 3, which is y to the power of 9. So now we can simply say 10x cubed minus 4y cubed. So these two cannot be added or subtracted because they are like terms. They don't have the same basis. Okay. Let me erase these ones there. Okay. Guys, factorize the following. Now we factorize the 6.2.4. We factorize 6.2.4. We factorize, guys. If you look at 16x to the power 4 minus 100, if you look at this, 16x to the power 4 minus 100. What type of expression is this? What do we call this expression? Guys, 16 is a square. 4 to the power 4 is also a square because it has a square root. 100 is a square. So this we call it the difference of two squares. We call it what? Difference of two squares. And how do we factorize difference of two squares? By opening two brackets. We always open two brackets if you want to factorize the difference of two squares. So 16 is a square. So there is first and first. So 16 is 4 by 4, 16. Then x to the power 4 is when we multiply x squared with an x squared. And remember, when we factorize the difference of two squares, the other one must be plus and the other one must be minus. So the square root of 100, so which is 10 and 10. So that when you multiply 10 by 10, you must get 100 there. Guys, sometimes you'd want to check if you are correct. Then you can simply check by multiplying out. Okay. The other one, 6.3. 6.3 is 3x squared minus 18x plus 27. Guys, the first rule in factorizing is to check for the highest common factor, or is to check if there's the highest common factor. And if there's a highest common factor, we remove it. So if we check it, 3x squared minus 18x minus 27, there's a common factor there, which is 3. 3 can go there, 3 can go there, 3 can go there. So 3 is the highest common factor. And what do we do with the highest common factor? We divide all the terms with the highest common factor. We divide by 3 plus 27 divided by 3. So, so this is 3. 3 by 3, they will cancel. 3 into 3 is 1. So, so this is x squared minus 3 into 18 goes 6 times plus 3 into 27, it goes 9 times. So now we have 3 into x squared minus 6x plus 3. So x squared minus 6x plus 3 is a trinomial. It can still be factorized, guys. So how do we factorize this trinomial? This one. Remember, we factorize a trinomial by opening two brackets. So it's going to be 3 into, you open two brackets there. So the first one is first and first. Then last and last is 9. So these factors of 9, they must be in a way that when we add them, they must give you negative 6. So it is only when you add negative 3 and negative 3 that they must give you negative, the middle term, which is negative 6. So it's going to be x minus 3 into x minus 3. Because negative 3 times negative 3 must give you now positive 9. Okay. Um, guys, so these other ones, I think they can be worked out. They are the same as those ones there. So I would want us to pass them because we've done something like this. We've also done the foiling method. So that is where you foil. So you use the FOIL method there. So this one we are going to expand, use the FOIL method, and you add. So 2.3, let me do 2.3 because 2.3 is different from those other ones. So in 2.3, 2.3. It's a factorize, so 2.3. Factorize. So guys, this is where we factorize by taking out a highest common factor. So it's 3a squared b minus 12a to the power 4b. So we need to take out a common factor. So let's start with the coefficient. 3 can be the highest common factor of 3 and 12. 3 can go into 3, it can also go into 12. So the highest common factor of a squared and a to the power 4 is what? It's a squared. Why? Because a squared can go into a squared, it can also go into a to the power 4. Then after taking out a highest common factor, what do? You open the brackets. When you open the brackets, what do you want to do? You want to divide both these terms by the highest common factor. That is how you factorize, by taking out the highest common factor. So it's 3a squared b divided by 3a squared minus 12a to the power 4b divided by 3a squared. Close your brackets. So now it's 3a squared, open your bracket, 3 and 3 cancel. A to the power of 2 divided by a to the power of 2, it's 1. Or it's a to the power of 2 minus 2, which is a to the power of 0, and a to the power of 0 is 1. So you are left with b there. Minus 3 into 12, it goes 4 times. So that is 4. A to the power of 4 divided by a squared is a to the power of 4 minus 2, which is a squared b. So b is b divided by 1, which is b. So that is how we factorize, by taking out the highest common factor. So let me quickly try out 2.3.2, which is a trinomial, minus 3x minus 10. Guys, how do we multiply the difference of, how do we factorize the difference of two squares and a trinomial? We factorize them by opening two brackets. Why? Because we can have a trinomial of this type only if we multiplied a binomial by a binomial. So how do we factorize this one? We open two brackets. So then your first factors, which is first and first, must be x times x, because x times x must give you x squared. And these ones, it must come, the last term must come from last, and it's negative. So it means one must be positive, the other one must be negative. So that when you multiply the last and the last, one must be positive and the other one must be negative. They must give you a negative number. And the last and the last, they must be in such a way that when we add them, guys, when we add the last and the last, the factors of 10. So these factors of 10, which one is positive and the other one is negative, when we add them together, they must give us negative 3. So factors of 10 are 1 and 10. So 1 and 10, even if one is positive or one is negative, they can never give you minus 3. But if we have 5 and 2, 5 and 2, they can give you negative 3 if 5 is negative and 2 is positive. When we add them, it's going to be negative 3. And what do I mean? Or where is this middle term comes from? It comes from multiplying outer and outer and inner and inner. So when you multiply x times negative 5 is negative 5x. Then you multiply 2 times x, it's plus 2x, which is going to give you negative 3x. So that is where this is coming from. So this is, it comes from multiplying outer and outer, inner and inner, you add them together, you get this. Because we know that this x squared comes from first and first, x squared, then last and last is negative 10. But the question now remains is, where is the middle term comes from? The middle term comes from I, O and I, outer and outer, inner and inner, from the FOIL method, from the FOIL. First and first, they must give you x squared. Outer and outer, which is x times negative 5, which is negative 5x. Inner and inner, which is 2 times x, which is 2x, and they're all like terms. When we add them, they give us negative 3x. So we are left with what? Last and last. Last and last is negative 2 times, 2 times negative 5, which is negative 10. So that is how. But when we factorize, guys, we only want the factors. So this is was just to confirm if everything is correct. So that is our answer there. So you factorize a trinomial by opening two brackets. That is what I meant to say. So something like this, we've done it, guys. We've done it. So I don't want to dwell much onto it. So unless if I dwell on the unless if I discuss number 2.3.3, factorizing by sign change rule. So this is 2.3.3, which is 4x into a minus b plus 3 into b minus a. So this one, guys, we need to factorize by taking out a highest common factor. So between these two terms there. So these are only two terms which are separated by addition there. We have a minus b, b minus a. They are not the same thing. So we cannot take it as a highest common factor. So we need to write this as a minus b. So which is going to be 4x into a minus b, then plus 3 into negative a plus b. So we haven't changed anything there. We just swapped a and b there. So nothing has changed. So now we need to make this bracket the same. So if we need to make this bracket the same, we need to have one a over b, a minus b, then we must have a minus b. So this is a minus b. Then how do we change this? We change this by multiplying the whole term with a negative. If we multiply everything with a negative there, this is going to be positive 3 times negative is going to be negative. Then negative a times negative is going to be positive. B times is going to be negative b. Now if you check there, these brackets are the same. Now we can take it as a common factor, which is going to be a minus b. Then what do we do with the common factor? We divide. Then if we divide the whole thing with a over b, we are going to be left with what? With 4x. And minus, if we divide this with a over b, we are going to be left with only 3. So those are your factors. So let me just quickly talk about this one before we go to the next page. Guys, I said when you multiply fractions and expression which involve fraction, you can simply look out the LCM. You can use the LCM method, which is what? So this is 2 over 1, which is going to be 6. Then what do? You take that 6, so this is 3x over 1 minus 1 over 2 minus 6 into the whole fraction is equals to 6 into 2 over 1. So this is 2 over 1. So now 2 into 2 it goes once, into 6 it goes 3 times. So this is now 3 into x, 3x minus 1 minus 3 into 3 it goes once, into 6 it goes twice, which is 2 into 2x is equals to 1 into 6 it goes 6 times. So this is 6 by 2. Now you can remember I said we can't have two equal sides. Now you can apply the distributive property there and there. 3 times 3x is 9x then 3 times what? -1 minus 3. So this one is -2 times 2x, which is -4x, is equals to 6 times 2, which is 12. Now you can group. So the unknowns will be on the left. 9x goes with -4x. Then the knowns must be on the right, which is 12. It goes with -3x, but it jumps equal sign and it becomes positive. So now this is what? This is now 9x minus is 5x is equals to, then this one it's 9. Sorry, it's 15. So it's 15. So we divide both sides by 5. So when you divide that by 5, you're going to be left with x. We divide 15 by 5, it's 3. So your answer there is 3. So guys, we need to move to the last, if not the least. Okay, number 7. These are what we call the functions, guys, functions. So let me make it a bit bigger and move it a bit to the right. Okay, read the flow diagram below and answer the question that follows. What is the output value of A? So they gave you a rule there. Guys, remember this side is your inputs. This side are your outputs. So your inputs are your X values, your outputs are your Y values there. So this rule, this is what happens, this is what you do to an input to get an output. So in other words, this is what should happen when you want to find an output. So our rule becomes Y is equals to a half X plus 2. So the first one, they want A, and A is an output. So they want an output when an input is -2. So they want the value of Y when X, which is an input, is -2. So in the space of X, we're going to substitute with -2 there. So Y is equals to half of -2, it's -1 plus 2, which is going to be 1. So A is 1 there. So the last one is B. B, they are looking for an input when an output is 4. So from the very same formula, in the space of Y, we are going to put 4. So instead of now substituting an X, we are going to substitute a Y and solve for X, because we are not looking for Y now, we're looking for an X. And how do we solve this one? You transpose this one to the other side. So it's going to be 4 minus 2 is equals to half X. So 4 minus 2 is 2 half X. Then what do we do now? Do we divide both sides by half? So if a coefficient is a fraction, guys, so we can simply multiply left-hand side and right-hand side by a reciprocal. So we don't normally divide by a half and a half, because we don't want to divide a fraction by a fraction. So if we want to divide a fraction by a fraction, instead of dividing a fraction by a fraction, we can choose to multiply that fraction by its reciprocal. So a reciprocal of a half, it's a 2. What is a reciprocal? A reciprocal of a number is the number that when you multiply it with a reciprocal, you get 1. So when you multiply a half by 2, it's 1. So a reciprocal of a half is 2. So you can simply multiply by 2, and you multiply this side also by a 2. So 2 times 2 is 4, and you multiply this side by 2. So 2 and 2 will cancel there. You'll be left with an X. So X is 4. So there it's your 4 there. Okay, guys, the same thing that happened to, no, it's not the same. Maybe we can try out 3.4. Maybe we can try out 3.4. 3.4. Find the rule in a form of a y. So let's check, guys. If you look at these ones below there, there's a difference of 3 there. From -10 to 7, they added a 3. From 7 to -4, they added a 3. So there's a +3 there. So this 3 can become a difference. You multiply it with what? With x. So it means they take a 3, they multiply it by the value of x there. You take a 3, you multiply it by -3, you get a -9. Then after getting a -9, what do? You again subtract by 1. So to get the answer there. So how did I get this rule? I checked my output there. So there was a difference of 3. So it's literally when you take this, you multiply by 3. Anything you multiply, so every time you multiply an input by 3, you subtract a 1. So you multiply by 3, which is going to be -6 minus 1, 7. You multiply by 3, which is -3 minus 1 is -4. So that is how it was found. So now determine the value of Q. The value of Q can be determined by using a rule. So which is going to be y is equals to, so we are looking for x when y is 8. So in the space of y, we're going to put 8, which is 3 times x plus -1. So this is supposed to be minus. -1. So which is 8 is equals to 3x minus 1. So 8 plus 1, we transpose 1 to that side. 3x, which is 9, is equals to 3x. We divide both sides by 3. So 9 divided by 3 is 3. 3 and 3 cancel. You are left with. So your x there is 3. So your q there is 3. Okay. So yeah, that is all about functions. So guys, the last one is going to be graphs. And I think that is going to be the last question before we close. Which is graphs, question 8. So can I drink water? Okay. Guys, so the graph below shows the number of push-ups that Angel did within a week. So the first one, 8.1.1, which day has the least number of push-ups? So which day has the least number of push-ups? So if you look at this graph, grade 9s, we have your horizontal axis, which is days of the week from Monday to Sunday. You've got your vertical axis, which is the number of push-ups. So what does it mean? It means on Monday, so Angel did how many? She did 10 push-ups on Tuesday. So this is your Monday. This is your Tuesday. This is your Wednesday, Thursday, Friday, Saturday, and Sunday. So it is the number of push-ups she has done per single day. So which day has the least? So the least would mean the smallest number of push-ups. So we look at Monday is 10. So it seems as if 10 is the least here. 10 is the least. So that was on Monday. That is the first question. Which day has the highest number of push-ups? So the highest number of push-ups, which were like 22 push-ups, it was on Thursday. So what is the total number of push-ups Angel did? So total number of push-ups, we add all the push-ups. So the first one is 10 on Monday, and that is between 12 and 14, which is 13 on Tuesday. On Wednesday is between 18 and 20, which is 19 push-ups. On Thursday, it's 22. Then on Friday, it is between 10 and 12, which is 11. On Saturday, it's 12. And lastly, on Sunday is between 14 and which is 15. So we can use a calculator there and make it a very quick. Let me just use my calculator and make it a bit quicker, which is 10 plus 13 plus 19 plus 22 plus 11 plus 12 plus 15. So we 1, 2, 3, 4, 5, 6, 7 for 7 days. So that is 102. It's 102 push-ups in total. Okay. Uh, um, is the graph linear or non-linear? So, guys, that is a linear graph because the line there is unbroken. It's a linear graph because it is not curved. So is the graph, oh, sorry. So this is supposed to be 102. So this is supposed to be a linear. So complete the following table of linear function represented by y is, okay guys, this one is almost the same as the ones we have done of input and outputs. So we are going to complete this by filling in, for an example, for the first value of y, we are going to use the very same formula, which is y is equals to negative 2x plus 1. So to find the value of y, we want to know the value of y when x is negative 2. So we can do it by substituting x by negative 2 plus 1, which is y is equals to 4 plus 1, then y is equals to 5. So there's 5 there. So the next one is y is equals to negative 2. In the space of x, we put negative 1 plus 1, which is 3 plus 1, which is 4. So there's 4 there, I guess. So the next one is going to be, guys, no, something is not right. Negative 2, negative 1, which is 2. So this is 3, guys. It's 3, sorry. So this is 3 there. then this is 1. So from 1 minus 2. So 5 minus 2 is 3. 3 minus 2 is 1. 1 minus 2 is negative 1. Then negative 3. So they say we must plot the points on the Cartesian plane. So this is going to be the first point, which is negative 2 and 5. The second point, which is negative 1 and 3. The third point, the fifth, the fourth point, and the fifth point. Let me do the last one. Guys, this one must be very much easy. You just go to the Cartesian plane. So the first point is going to be 2. So the points there, ordered pairs, let me write them down. Okay. Let me write them down. Ordered pairs. So 8.2. So the first one is going to be negative 2 and 5. The second one is going to be negative 1 and 3. The fourth one is going to be 0 and 1. Then 1 and negative 1. And lastly, 2 and negative 3. So these points can be plotted on a Cartesian plane. After plotting them, you join them together to form a graph. So the graph is going to be a straight line since they say it's a linear function there. Okay. Let me do the next one before we close. Okay, they say use the dual intercept method to plot the linear function represented by y is equals to x plus 4. Okay, they say use the dual intercept method. Guys, the dual intercept method is the method which uses the x-intercept and the y-intercept. So this is 8.3. We can start by calculating the y-intercept. And remember, for y-intercept, what do? We let x be equals to 0. And we are going to, in the space of x, we are going to put 0 using the very same rule. So the rule says y is equals to x plus 4. So we want to calculate the y-intercept. So to calculate the y-intercept, we let x be 0. So meaning in the space of x, we're going to put 0. Why do we do that? Because we know that in the y-intercept, it is point on the y-axis where the straight line is going to pass. So if the straight line is going to pass on the y-axis, any point on the y-axis x is 0. The reason why we put 0 in the space of x. So y, it's what? It's 4. Because an intercept is a point, so we are going to write it as a point intercept. Like we said, it's 0 and 4. So for x-intercept, let me do the x-intercept on the side there. We are going to let y be 0. And if we let y be 0, from the very same y is equals to x plus 4, in the space of y, we are going to put 0. Why do we put 0? Remember, the x-intercept is the point on the x-axis where the straight line is going to pass. And everywhere on the x-axis, the value of y is 0. So this is 0 minus 4 is equals to x. So this is negative 4. So because it's a point, x-intercept, because it's a point, it must be 4 and 0. When x is, so this is x, this is y, this is x, this is y. Now we have our intercepts. Then what do? They say on page 8, on Anisha 8. So we can simply go there. So the y-intercept is 0 and 4. So the y-intercept is 0 and 4. The y-intercept is a point on the y-axis. The y-intercept, that is where it's going to pass on the y. So they say it's 0 and 4. And where is 0 and 4? 0 and 4 is there, exactly there. And the x-intercept, is negative 4 and 0. And where is negative 4 and 0? Negative 4 and 0 is there. Now, we can simply join the lines together to form a straight line. So it's supposed to be a straight line like that. Okay, okay, supposed to pass there, pass there, pass there, pass there. Okay, guys, that is how that should be done. And lastly, 8.4, determine the gradient of line CD with point C, which is 4 and negative 6, and D, which is 2 and 5. Okay, how do we do that, guys? How do we do that? So that is the gradient. They want the gradient when we are given 2 points. So the gradient when we are given 2 points, guys, we know we use the formula. And the formula of the gradient we know is gradient M, 8.4, gradient, which is M, is equals to y2 minus y1 over x2 minus x1. So you can simply come there and make this x1, y1, y1. Then you make this x2, y2. So therefore, y2 is what? It's 5 minus y1 is 4 over x2. Our x2 is negative 2 minus our x1 there is 4. No. Y2, which is 5 minus negative 6. It's 5. Okay, let me erase this one. It's a mistake. So this is supposed to be y2, y1, x2, x1. So y2 is supposed to be 5 minus y1, it's negative 6 over x2, it's negative 2 minus 4. Okay, let me push it up. So which is 5 plus 6 over negative 6, which is negative 11 over 6. Guys, the gradient can be left even as a fraction. There's nothing wrong in doing it like this. So, okay, guys, that marks the end of our revision session today. I know it's a bit long. I hope you guys enjoyed the lesson. I hope you understood or you grabbed this lesson or the explanations. Guys, this question paper is going to be shared also on the by a link on the description. So I'm going to share this document also on the channel. On the description box, I will share the link. And And any other important resource that I feel like I will share. I will also share the other platforms such as TikTok and other social platforms where you can be able to reach out to me on the description box, so that if there are questions that you want to ask, you can always ask. Guys, please, again, don't forget to subscribe so that next time when we put out another content, you can be the first to know. And if you really liked the video or the lesson presentation, please give me a thumbs up. You can also click a like there now, guys. You can click it now. Click, guys. Please don't forget to subscribe. Thank you until we meet on the next episode. Thank you.